This is an unintended solution to challenge EZMD from 0CTF 2025. This was a hard challenge because only 5 teams managed to solve it, with over 400 teams playing the CTF. The whole challenge presented a Markdown renderer in which we could provide a name of the file and some Markdown. After a while, the Markdown has been rendered, but only on the server side. Firstly, I will present the unintended solution and then I will guide you through it. Enter the description, click submit, Ctrl R to send to repeater. Let's drop the request. And now let's go to generating our payload. Okay, we have the F name and the content. Let's paste the F name first. Let's get the content. Okay. Now we can set up the webhook to catch the requests and send the request. As you can see, after a while we get some requests, a new image shows up, and here is the flag. So that was the exploit in action, and now let's look at the source code to see how it actually works. The EZMD challenge contains a code server.tar, which is pretty large, so I didn't even bother opening it, and I focused on the bot logic. When I saw this specific line, it reminded me of a challenge that I did in the past for Ping CTF 2023. The challenge was called I see no vulnerability fixed, and it revolved around replace function in JavaScript. This will be important later when we discuss the exploit itself. Let's go to the render endpoint. Firstly, it gets the content and the F name from the request body, and then it sanitizes them with the use of DOMPurify sanitize. The challenge uses isomorphic DOMPurify of the latest at this date version. After sanitization, it goes to the render function. In here, there is a bunch of code responsible for rendering the Markdown file into a PNG, but I will focus on the result.html file. Let's see how it actually looks like. As you can see, it's pretty simple. It only contains this file name in brackets and the image src with a hard-coded image.png. There's one unusual thing, which is the language ZH, which is for Chinese, but considering that this is a Chinese CTF, I didn't focus on that part. And here, the file name in the brackets is replaced with the sanitized F name. After that, we can see the image PNG being created by the Markdown rendered file. Then the bot creates a new page, disables the JavaScript on it, goes to this newly created index.html page, waits for 5 seconds, and then closes it. It's worth noting that the bot container has access to workspace and www volumes. The code server actually has the flag and also has access to workspace volume. The www container, which is responsible for displaying the index.html, has access to volume www. This layout already hints that we need to obtain the flag by embedding it in the Markdown and then by sending it using the web container. However, as specified in the title, this is an unintended solution. So if you would like to see the intended one, I recommend reading the author write-up, which I will link in the comment below. So let's start actually exploiting the challenge. It's worth noting that when we see the following pattern, some secure sanitization, JavaScript replace call on the sanitized variable, returning the raw HTML thinking that this is safe, should always be a red flag for you. This is because the sanitization is being done before any data manipulation, which is an anti-pattern, and we typically want any sanitization to be taken just before the render. I'm pretty confident that most people think that the replace and replace all functions switch the value of one string to another in some string. Like for example, having the a string in v1 variable, then calling a replace function with the search string and the replacer string, and then expecting the output for the replaced string, which is true. However, the second argument, stating what should the first one called the pattern be replaced with, is not a string, it's called the replacement, and that replacement can be either a function, and that doesn't really help us, or a string with a number of special replacement patterns. I'm currently on the Mozilla developer page, which defines the replace function. Let's scroll down to the parameters. As you can see, the replacement parameter can be a string or a function. However, a number of special replacement patterns are supported. Let's see them. This is the table of the special patterns. As you can see, they all involve a $sign followed with something. We are interested the most in these two. The first one inserts the portion of the string that precedes the matched substring. Let's see how it works in practice. As you can see, I want to replace the character B with 1, then this special pattern, and 2 to see what the pattern will look like between them. As you can see, it just copied the portion of the string that preceded the matched substring. The single quote works pretty similar, but it matches everything after. For example, if I have the B at the start of the string, and I would call the same replace on the B, but with a different pattern, it will insert the portion of the string that follows the matched substring. Knowing that such mechanism in JavaScript exists, we can start to try and bypass DOMPurify sanitization in the fname parameter by including something that is not evil payload, but some widely accepted pure string, like src of an image. We can test whether it's accepted with a simple Node.js script importing the isomorphic DOMPurify with the exact version that is used by the container, sanitizing the payload and outputting the sanitized one. As you can see, DOMPurify didn't delete our image src. We can test the payloads fully with the template from the actual service, creating our payload and including the XSS in the src parameter, and then prepending it with $ and a backtick. Then we can call DOMPurify sanitize on our payload and check whether DOMPurify is rendered, so whether it removed the payload or not. Then we can call the replace function on the clean payload and console log how would the index.html look like. Let's now test our proof of concept. As you can see, we are assured that our payload was not detected by DOMPurify sanitization. And in the output HTML, you can see all of that being the found replacement before the replacement pattern. And as you can see, here is our XSS payload. Let's see if this HTML actually executes the XSS. Success! It popped an alert, so that means that we have an XSS in the fname parameter. Now we can begin constructing our XSS payload. Let's start with a simple main function that will be executed on the both side. Firstly, we want to fetch the image PNG. We convert it to the blob to make it easily transferable. Then we need a webhook. I set up a simple webhook under my domain, and I'm just fetching it with the post method and the content tab image PNG. Then we base64 the whole payload and copy and paste our fname XSS payload. Of course, we don't want an alert function here, so we call an eval, we decode from base64 and replace the base64 payload. When I tried submitting it, I was a little bit confused because I didn't get anything on my webhook server. And that was precisely because of this line here. The bot page didn't have JavaScript enabled. But the default behavior of page is that the JavaScript is enabled. So if we manage to open a new page, it would have the JavaScript enabled. So all we need to do is to have an iframe that will just open the www index.html, so exact same site, and that would have the JavaScript enabled. That means that our XSS will eventually evaluate. Let's now create our webhook using Python HTTP server. So firstly, we need to import necessary classes. We define a class inheriting the base HTTP request handler and then just start it. We need to handle the post method because we are sending the image using a blob. We read the body, open a file and write to it. We also need some course headers in order not to get just the options request. After adding that, we also need to host an iframe, and we can use our web server to do that. Let's define our HTML, where we call the Window.open on www index.html, and just returning this HTML content when responding to the GET request. This setup here is sufficient enough to get the rendered image PNG. Let's focus now on embedding the flag. By default, DOMPurify sanitizes any iframe included in the payload. So that wouldn't be enough because DOMPurify would get rid of it. So we need to actually move the closing tag to the next line and wrap the iframe with a code that will consider for HTML being safe and for Markdown being a valid iframe. We can do that by putting an image src in a code block and ending it here. Using HTML highlighter shows us that this is treated as a simple string. If we change that highlight to Markdown, we will see that this iframe is actually a part of it, so it would actually include the flag. So using this payload as content will be considered safe by DOMPurify as a test by default for HTML and not for Markdown, and that is how we receive the flag.